What is the Fresnel distance ZF? You see, it is such a distance of the screen from the slit at which your y, the spread, right, a small y, the spread will become equal to d, a small d, correct? So that spread is whatever linear spread is there, that will of the center maxima, that will be equal to the size of the slit or hole. That is what we can say. So, well, I can write here as, you can note down along with me, the distance of screen we can write from slit at which the diffraction spread what is that? This diffraction spread is nothing but your y. In the figure you can check it. So that become of the beam of light, we can write rather of a beam of light. You can write a beam of light that becomes that is equal to size of the aperture, we can simply say. So beam of the light is equal to the size of the aperture. That is, your aperture means slit, right? This is your slit, or we can say hole. If it is hole, then yeah. So that is known as your Fresnel distance. Got it? So note it down, then we'll discuss further. Constant, let me know, please.
Done, sir.
Done. So
Yes,
in
sir.
that case, yes. So in that case, if you want to write mathematically, we'll be using the same y is equal to lambda d by d, right? So what you want to have here, y will become, your y will be d only, the size of the slit, right? It is happening. Your y will be d here, and your d will be, capital D will be ZF, yes or no? So if you take here in these two things, what I'll be getting? I'll be writing small d here, lambda. In place of d, I'll be writing ZF, and then d, normal d, as per the formula. So yeah, I'll be getting my ZF, which is equal to d square by lambda. So this is your ZF, right? So conceptually also and mathematically also, you must know this. Now, if your ds, the distance of a screen from the slit, if it is less than ZF, yeah, we can say that the ray optics is valid. You are able to understand that, right? If that fellow ZF is your d is less than ZF, because ZF is a point where your y becomes exactly equal to d. How come? You see, y is directly proportional to d, capital D, for the given lambda and d, small d, right? Y is directly proportional to, from here, we can say your y is directly proportional to capital D for the given lambda and small d. Can we write like that? So if I'm decreasing the d, this capital D, I'm decreasing my y for the given conditions, right? So ZF is already the critical point where we start getting the, we can say the spread is negligible, and hence we can say the ray optics is valid. So if it is less than that, if your capital D is less than ZF, is still better. You'll find y will be still smaller. So you'll find that that point on the screen will be still closer to O. So, well, it is ray optics is valid. So, well, I can write from here the same. If your D is less than your ZF, then what we can write? Then you can say the diffraction effect. The diffraction means the bending, correct? So diffraction effect will be, yeah, diffraction effect can be neglected in that case, can be neglected, right? Can be neglected, and we can say that ray optics is valid, right? If diffraction is not there, then they are on the straight line. We can say the all the rays coming out of from the slit all are almost parallel to the each other, right? And then they are going straight. So the ray optics is valid, right? We can say here ray optics is valid. And now the other way, if your D is greater than ZF, then appreciable, yes, diffraction can be seen, right? So spreading, we can say if it is greater, then the spreading due to diffraction, we can write that spreading due to diffraction yeah will be appreciable, will be is, we can say, is very pronounced. You can see easily. And in this case, what we can say about the ray optics, whether it is valid or not valid, yeah, Rishit, ray optics, valid or not valid, what we should write here?
Valid.
No, it is a spreading is there. So there is a question of, if D is greater than ZF, your Y will be greater than your small d. So spreading is there. If a spreading is there, then your ray optics is not valid. Ray optics need a straight line. We know that ray optics is that the light travels along the straight line. Am I right? That is what we have understood earlier. So in this case, once the spreading is coming, there is a question of ray optics. So ray optics is not valid in this case. Clear why it is not valid?
Yeah.
So questions are there from this area. Very important thing. Fresnel distance is important thing. So you please note it down once done. Let me know. I'll go further.